Hello guys, today we're going to be talking about searching algorithms. So, why do we need to know about searching algorithms? Let's say you want to search something on Google and you're really curious on how it works. So, how does a searching algorithm work in this case? So, let's say you want to search up how does a searching algorithm work, right? So, the Google searching algorithm goes through all the data set and searches for this thing and then it gives it to you. That's what we're going to be talking about today. How does this process work? What is a searching algorithm? As in the example I said before, a searching algorithm is basically an algorithm that searches. It's practically in the name. Searching algorithm. So it's basically just an algorithm that searches. So how does this work? So there's many different ways how searching algorithms works because there's many different ways of how to do a searching algorithm. So let's just talk about the basics of a searching algorithm. So let's say you have an unordered pair, right? And even for an ordered pair, we can just give it. So let's say we have an ordered pair 1, 2, and then 4, and then 6, and then 8. And then this is from this is in ascending order. And then let's say you want to search for the number 4. Then in this case, we gonna use a searching algorithm to find the number 4. And then once that process goes through, we'll have the number 4 in our hands. But this is the process that we're going to be looking at today. What is this process that's getting the 4 to you? So there's many ways that this happens. And even with unordered pairs, there are some searching algorithms that deals with these. So we're also going to be talking about the advantages and disadvantages of every single one. So let's move on to our first searching algorithm. This is the linear search. So if you guys like math, which I don't know if a bunch of you do, then you've probably learned about like linear slope or like linear. So it's basically when you do something one by one. So unlike let's say binary, which is 2 by 2, linear is 1 by 1. So you basically just implement that into a searching algorithm. So you search it one by one. So let's say you have an ordered data set. It doesn't have to be ordered, but let's just take an ordered one in this case. So let's say we have an ordered one saying like 1, comma, and then 5, comma, 7, comma, and then 8, 9, and then 10. And then we're going to search for 8, right? So the searching algorithm, which is linear search, will have a pointer here, and it'll basically go through every single one searching for the number 8. So let's say we're searching 8, then it will check, is this 8? And then let's say it's no. Then it will check, is this 8? And then we'll say no. And then is this one 8? And it'll say no. And then finally when we reach 8, it'll say yes, and this is 8. So it'll cut off the program and then give you the output of 8 and how you got it. And this is basically how linear search works. So what are the advantages? So ADV, shortened for advantages. And the advantages is that it does not have to be in order. So let's say the 10 was over here and everything. So let me just make a new data set. So it's let's say 10, 1, 5, and then so on. And then we're searching for the number 5. So we can always just check, is this 5? And then is this one 5? And then is this one 5? So this doesn't utilize the factor of an ordered data set. So this can be an advantage. So it does not need to be sorted. Need sorted. Set. So it does not need a sorted set. So, and what other things are there? So what are the other advantages of linear search? The other advantages is that it's a pretty like good algorithm for beginners. It's not good, but it's not bad. So that's not going to be an advantage. What are the disadvantages? So disadvantages, let's just put this for short. So the disadvantages would be that it's kind of slow compared to other algorithms, which we're going to get a hand on later. but this one's kind of slow compared to the other ones. It might seem fast right now, but it's kind of slow. And then we're also gonna see how it's only an n time. It only has an n time complexity. No, it actually no, cut that out, cut that out, cut that out, cut that out. Whenever I'm editing this video, cut that out. So the disadvantages is that it's slow. It's like really slow compared to the other algorithms. But it does have an advantage, thankfully, that it does not need a sorted set. So let's move on to our next one. So our next one is gonna be our binary search. And just going over this, there are many types of these searches. This is just an overview of the categories. Like there's many different types of binary searches. There's many different types of like linear searches. So now we're moving on to binary search. So this is basically a search that splits like a data set into two. So it's divide and conquer strategy. So let's say we have a big data set and it has to be ordered. So that's a disadvantage, but it has to be ordered. So let's say 1 and then 3, 4, 5, and then 6. Then a binary search basically searches through the algorithm by splitting this data set into half each time. So it divides and conquers. So let's say it's searching for 6, right? And then it divides the data set right here. This is not applicable for every binary search, but I'm just giving you an overview of a binary search. So let's say we're searching for this number 6, right? So we know it's ordered, so we split it right here, and then the number right here is a 4. Is 6 greater or less than 4? Because if it's less than, then it will be over here. If it's greater than, then it will be over here. So since it's greater than, then we have to take this part. Then we have 5 comma 6. And then we split in the middle. Is this one 5? It's greater than, right? And then what's greater than 5? And then 6. So we're down to 1. And this is definitely going to be our thing. And if it's not 6, then 6 is not in this entire data set. This is really efficient for bigger data sets because as you scale bigger, it just takes one more step to scale it in half. So let's say you have like 1,000 data sets, right? So if in order to get it from 1,000 to 500, all you have to do is one set of operations. So one splitting in half and checking on which side it is. Unlike linear search, where you have to go through each 500 to cancel out 500, which is going to take much more time. So binary search is really effective for big data sets, and there's even like faster ones inside binary search, but we'll talk about that later. So what are the advantages of binary search? It's that it's really fast. It's like fast, so speed / fast. So what are the other advantages? Is that it's very like it doesn't take a lot of data in most cases, but there are some that do split it. So we need more data for these ones, like the ones that split it into more and then take these types of data. But there are binary searches that take it in place. So it like cuts it in half and does all that in one place. So data advantage, which is also for linear search. So keep that in mind. Data also goes for linear search. And then the disadvantages, I'd say, are that the binary search actually is like not like it cannot work on unordered pairs. So cannot do unordered pairs sets. So it cannot do unordered sets. So let me move this. So at all, like it cannot do unordered sets at all. So moving on to our next searching algorithm. So our next searching algorithm is going to be about ternary search. This is like binary search, but splitting into 3. Like I said before, there are many types of ternary search, but it is actually less known. Ternary search is also really effective. So it basically splits a data set into three spots instead of two. But if you keep going on with this pattern, it actually gets less efficient. Only binary and ternary search are really effective, but if you keep splitting it more and more, it's not going to get that effective. So ternary search, it basically like binary search, but it splits it into three. So let's take that data set. So 1, 5, 6, 7, and then 8, and then 10, right? So let's say we're trying to like find the letter 7. I mean the number 7 in this case. So we're going to split it into 3. So this is going to be 1, and then this is going to be 1. So they try to get the almost the same amount of ones in each. And then first we start off with this one. Is the number 7, which we're looking for, greater than or less than 7? I mean, greater than or less than 5? So it's greater than, right? So it has to be, or is it 5? So it's not 5, right? And then it's greater than, so it has to be part of this group. And then we look at this one right here. Then we look at, is it less than or equal to 7? Since it's equal to 7, we found it right away. But if we were to take 6 as the one that we're trying to find, then we had to go one step further. So then after we cancel these two out, so these two ones, then we have 6 and 7, and not don't say 6, 7, or you can if you want, but like just enjoy. But like yeah, you can say 6, 7, but this is really like what you have right now, and then we split this into 3 pieces. But since we don't have a lot of spaces, then we can really just split it into 2. So we have one right here and then one right here. So this is technically nothing, so it's in these 2 spots. And then this is the one that really matters. Is it this one or this one? So it checks, is 6 this one or greater than or less than it? So 6 is this one, so we found our search. But in bigger like spaces, just like binary search, it's going to be really effective. So let's say we take 999 since it's divisible by 3, but it does not have to be divisible by 3. So if we take 1,000, then we try to get the most equal parts as we can. So since we took 999, in one step, it's going to be 333 left. So 333 left. And then if we do one more, that's only going to be 111. If we were to do that with linear search, then that would only take us to around like 997 out of 999 that are searched. And in linear search, in rare cases, it's very lucky that like the first one that is searching is 1 and 1 is the answer. But we're not talking about these cases. We're talking about the overall case. So the next one that we're going to move on is to two-pointer search. So this is basically just like linear search, but it's with 2 pointers instead of 1. So a pointer is the thing that we're searching for. So there's 2 pointers in this case. So let's say this data set, it does not have to be ordered. So this one is just like linear search, but it's with 2 data sets. So it's gonna be like 1, 2, and then 5, 7, and then 9, let's say, right? And then first we start off with this one. So we're trying to find the number 5, let's say, right? So we start off with this one. Is the number 1? So it's no, right? And then we then go to this one. Is number 9? No. Then we move this one side by 1. And then we look here. Is it number 2? No. Then we go side over here. Is number 7? No. And then we go side for here one last time. Is number 5? Yes. So it basically comes from each side instead of just one side. So this again is gonna be a very good searching algorithm since it used 2 pointers. And one very big advantage is that it does not have to be ordered. So advantage is that does not need ordered. So ordered, I do not mean by like Amazon package ordered. I mean like ordered in a pair, but like it does not need an ordered. So, and then one of the disadvantages is that it's very slow compared to other algorithms, as we saw before. Like this one, if we were to take it, then if we did 2 total, since it comes from both sides, then we would only get 4 done. But you can't just keep on adding like pointers. Like we can't just put a 3 pointer, 4 pointer, 5 pointer, because that will just really decrease the efficiency. Just like what we said for binary and ternary search. So the disadvantage is that it's slow. So moving on to our next searching algorithm. This is gonna be the sliding window search. So this is basically a special type of searching algorithm. So let's go back to our Google example, right? So let's say we're searching something in Google. A sliding window basically searches over the data set while keeping that condition in mind. So let's say you're trying to let's say you're trying to find like a number less than 2, right? So this pointer keeps a condition in mind and then like keeps on going and then finds all of them that like meet that condition. So let's say like the condition, let's say we said whatever is a sorting algorithm, right? So it's gonna find everything with a sort and an algorithm in it. So those are the two conditions, and it's gonna go over all the data sets. Let's say that's how Google works. It's really not, but let's just say in simple terms, that's how Google searching algorithm works. So let's say in like instead of words, let's say numbers. So let's say we have 1 comma 2 comma 4 comma 6. Then let's say we need a number like greater than 2. We need a number greater than 2. Let's just take this greater than, not the less than accidentally drop. So we need a number greater than 2. So I'm just going to put n is greater than 2. So we need a number greater than 2. So we check this one. Is this one greater than 2? It's not, right? So let's move on to our next one. Is this one greater than 2? No, because it's not greater than equal to, it's only greater than. So then we'll move on to our next one. Is this one greater than 2? Then yes. So they're going to give this one to us. And then, is this one greater than 2? Yes. 6. And then it basically keeps a condition in mind while going over it. This is basically the essentials of a sliding window searching algorithms. It's not like the ones that we talked about before. This is basically like an entire topic on its own because it keeps a condition in mind and it's really different. So talking about these different types of topics, let's go on to our hashing one. And the advantages are really different because there's a bunch of ones in here. So we can't really describe all the advantages and such. So moving on to our next one, which is our hashing. So let's like basically define what a hashing is. So whenever we're given an input and we want to store it for the short term, we give it to this thing called a hashing thing. So we basically give it in. Our input is the key. So we give it into this function and it basically has a table and then it maps it to one specific number. So let's say this is table number 1, 2, and 3. So when we give it our key, then it'll basically map this one to a specific one. So let's say the function is like the first letter of the alphabet, and each alphabet like has a corresponding number to it. So like A has 1, B has 2, C has 3, and so on. So let's just say we have this key, and then the thing that we're keeping is someone's names like that has an A at the starting of it. So Avid. So let's say Avid here has like his name started in A, so it has Avid here. So this is basically the essentials of a hashing function. And then this is basically the searching algorithm we're talking about, is where we give the key and then we can retrieve this Avid back. So if you give the key to our function, then we can have this Avid back. This is the essentials of a hashing So this is how hashing works. It's not really like the sorting algorithms that we first talked about, but this is also important to know. And this is a way to get stuff to your information. So it has the same essentials and it gives what you need, but it has different characteristics basically. Moving on to our next one, we have our tree or prefix tree. So tree is spelled differently, not tree, Tree. And we basically call it a prefix tree. And this is the actual tree. So prefix tree. So what is this? So in like the beginning, we create a tree that basically maps to everything else. So let's say we want to find someone's name called Sam, right? And then we basically split it again and again, and then this one splits into 3, let's say. And then to find Sam, we have this one. So it goes through here, and then it basically tells us like which way to go. So let's say, but like more than the letter E is gonna go this side. So we have the letter E here. So more than the letter E here. So then we go here, and then let's say if the thing is between Q and like X, let's say, it goes in this middle one. So then we go repeatedly to this middle one, and then if it's S, then let's say we go to this one, and then we have to move down a bit. So let's say if it's S, we go down to this one, and then let's say if it's SA, then we go to this one, and then if it's SAM, then we finally find Sam here. This is a prefix tree, so it's basically a pre-made tree that basically helps you like find something. In this case, we went down this prefix tree to find Sam, but we can just try another name, and then we will go down the same prefix tree and then find it in the tree. So if we're searching for something or someone, this is how you can find it in a prefix tree. So you can search for Sam, and then you can find Sam and then retrieve it, all the information along with Sam too. So this is basically the end of our searching algorithms, and I hope you like this video, and bye, and I hope to see you next time.